Hello, I'm from the Digital Hub Dental Clinic. My name is Chun Se-young. Today, we are going to look at as part 8 of this lecture series on the one-day inlay design. First, when it comes to inlay, this is a case where I did with the one-day inlay. Due to caries number 37, inlay treatment was planned, and as you can see, preparation was done, and then using the oral scanner, you can see the scanning is also done. Actually, the patient was scanned with TO3 and without much problem. The scanning was done quickly. Inlay scan, especially one-day inlay, is the topic of this lecture because when it comes to crown, bridge, or dentron, code packing or other, while scanning, there are challenges. But in case of inlay, in scanning, actually, if you just do thorough scanning, then without much problem, you can do good prosthesis production. So in inlay, the difficulty of scan is the least in using the CAD-CAM. So if you are using the CAD-CAM for the first time, then rather than doing other treatment, like you can see, it's easiest in terms of scanning. It's better to start with the inlay. So the CAD-CAM solution with the one-day concept, it's very feasible and easy to do compared to others. So scanning is complete, and 3Shape or ExoCAD, the prosthesis CAD software is used for the inlay design. Let me explain that with this video. So this is 3Shape Dental Manager CAD software, and using this, various prostheses from inlay, abutment, implant, dentures, and other orthodontic devices can all be designed. So now you set the occlusal surface, and that procedure actually is what you need to do as first step. And you have also this digital, orthodontics solutions. And to make all the process easier, you need to set all the points, and then you need to do point setting very thoroughly. So first, the section you need to design inlay for, the section of that tooth is set with the lead line. So this is for the setting the inlay margin. The accuracy of this margin determines the fitness and actually determines the quality of the prosthesis. It's the first step toward having good results. So margin setting is something I pay a lot of attention to. Having accurate margin, create good prosthesis so that it would have a best fit for the patient is the aim. And while if I do this process myself, then I can also do the prep much better. So the preparation, I think, have gotten better with thanks to the CAD-CAM because I start with the CAD-CAM first. Using hand pieces has become for me also better. So I think using CAD-CAM has been very useful and helpful for me. So in margin setting, it takes a bit of time, and the current CAD software margin setting, the ones that can be done automatically is currently being developed. So very soon, this complicated step probably and hopefully can be done easily and very quickly. And I hope such a system will become available very soon. Now, using the this dot point, the margin is set very precisely, and creating milling inlay with the milling machine and using the 3D printer for doing your job. The margin setting is a bit different between the two, and that difference I will explain in my offline lecture and share with you also my experiences. This lecture doesn't have give much time to also go into this detail. But anyway, margin setting is something that you need to invest a lot of time in and do very precise. Now, in doing precise prep, when we did analog approach, if there's something that falls short, then lab technicians made the adjustment so that the final result of the inlay would have a good fit and delivered to our clinic. But in the digital system, the disadvantage is that that's not possible. That consideration cannot be made because it's very precise, so it cannot lie, or it cannot really have a room for compromise. So in doing preps or other steps, all needs to be done very precisely. So you have to be very precise in CAD scanning to ensure that you have a high quality prosthesis. So where you see the prep location and the tears of the teeth, it's not really clear. But if you do it many times, what is real shape and how to do when you prep this area, the expertise about this area you can gain very quickly. So please pay attention to this. And this border area, the inlay borders are like knife edge, very thin, but and can be printed with the 3D printer. But in milling, if you cut, it can break because it's thin. So you have to take that into consideration in prep to have a good inlay results. Now, all margins, I do believe, have been set precisely, and as you can see here, using the CAD software, set margins, and you enlarge the image in doing that work. So how the prep is done, in other words, you can see what this enlarged image. So using the CAD, you see the work can be very precise. Of course, whether you have done prep very well, you can see clearly what this image is. But with the margins setting, with this enlarged image, means that the CAD system can now, distinguish this up to this very detailed level. It has become that precise and accurate. So the inlays that's been made with the CAD system is very precise. It's really clinically has a very good results. So it has become very dependable solution. So if you design with such effort and time investment, can it really done with one day, you might ask. But if you become accustomed to this in design one inlay, within 5 minutes, you can complete your design. And the 3-shaped dental desktop, which is another chair-side solution. And in that chair-side solution, the margin setting is with the help of AI, it actually can be done more or less automatically and further cutting down the time investment. But here, because it's a lecture, I wanted to show you what workflow is used in making the inlay. So to show you each detailed step, it took a bit time. But anyway, once the margin is set, then number 46, anatomy, the clown library will be something I will call. So roughly the tooth shape and form will be set. And with that, occlusion tables and with the occlusions, and as you can see, the inlay is automatically created. And because of this advantage in the CAD-CAM system, it can be finished within a day. Now, the red area is where the inlay thickness is a bit falling short, and the margins or the grooves are, if it's falling short, then here we can make the adjustment and corrections. If we were to do through the labs, using wax up or ingot, when we had the analog approach, then this is the part that took the most of the time. But thanks with the CAD-CAM system, the part that took most time can now be done very simply, in a short time, with the result being very high quality. So with one day or one business day, inlay or crowns can now be made. So the groove or thickness, the minimum thickness on the software side, if you put in the limit or the threshold values in the system first, or ceramics or hybrid resin or other materials properties, or the set values are input, then there will be no problem in creating prostheses in milling. And in other words, stable result can be made in the system. So it can be set. The prosthesis can be set very stably, and in using this inlay, the patients will find it comfortable. And because of all this, the problems can be prevented beforehand. So this means that high quality prosthesis will be offered to the patient and to the dentist. And because of that, in many aspects, this is very useful and helpful system. So while talking about one day inlay, the strength of the digital systems, one day inlay is possible, and I'm really glad that this is now possible. And now the final step, the most ideal fit to the teeth and occlusions are also considered in design, and this is the final step. So as they say, if it looks good, it tastes good. So now I want to make it more aesthetically pleasing inlay design, because that makes you feel good as well as the patient feel good, and that is what I'm doing now. And this inlay design is now all finished, and it's now being saved. And for this lecture, it took about 10 minutes or so, and I also did some editing. But once you get accustomed to this, then I assure you can design inlay within 3 to 4 minutes, making the one day inlay really possible. So that was the prep scan image, and this is the inlay design image. And this 3D data is printed using the 3D printable files, and that inlay is made. Only 1 or 2 years ago, or if it's inlay, actually only a few months ago, blocks had to be milled. But now, with the usage of the 3D printers and 3D printable resins, can now deliver good strength and long-term stability. And now the type of products are now becoming available on the market. So today, milling inlay and printing inlay, these two will be what I'm going to explain to you about one-day inlay design. So with this designed inlay, let's now talk first about the milling inlay. The materials used for the milling inlay, something you know very well, like this on the left, is this block type, all ceramic, hybrid resin, and other ceramic materials. So whatever the materials, I do believe can all be used for inlay. So this block type materials using the milling machine, you cut, then as you see on the right side, that inlay will be created, and before setting to the patient, this will be how the inlay would look. So in the milling machine, you can use the block type or like this disc type material can be used. So let me explain about this. So this disc type is within one disc compared to block. You can have more numbers of inlays milled. So economically, it's very attractive. And this is hybrid type resin, and it's very good material. And as inlay material, at our clinic we use this quite a lot. So in this disc type or in the block type, the 3D SD file can be used to set the data and to do the cutting. In previous lecture, I talked about the CAD-CAM system and told you that CAD and CAM system do exist, but the design software is CAD, and using the milling machine doing the production. And with the milling or 3D printing, before you do that step, the software used for operating that is the CAM side. So this is CAM. So in the disk, where to position the inlays, and using milling machine when you do the cutting or milling, which burr needs to be used, and all this needs to be calculated beforehand. And software used for that calculation is CAM software. And using the CAM software, the inlay positions are determined, and then the calculated tool path or the values are given to the milling machine. Then you go to the next step of the inlay production. So I prefer the disc type because if you can use the block type, but using block type, MO cavity or O cavities inlay, in that case, the support or the connection part is needed. But that means sometimes the contact point is not very precise, and the occlusal surface can be distorted, which means you have to make adjustment for the occlusal surface and the contact point, and that is quite burdensome and takes a lot of time. So I do the embedded approach. So the inlay, the occlusal surface, and the bonding area, you divide that into two areas. So first, the bonding area is cut first, as you see on the top image, and once that it is then it's milled, then the stone is mixed, stone that can be hardened very quickly, and on the opposite side, the occlusal surface is milled again. So two-step milling is used to make the inlay. And the advantage here is that after completing the inlay, you just remove the stone, then you can just deliver completed inlay to the patient's mouth. So very easily. So since few years ago at our clinic, we like this inlay production step. So this is the clinical case. As you can see, number 7 or 6, the fatness is really good, and it's really good, looks well fit. If you just remove the resin cement then I think we can gain a very good margins. And the bonding material is resin cement, so it's very good for bonding. And even if it's not best fit, or if there's a dead space, then with the resin cement, it can be covered. And clinically, it's the CAD-CAM inlay advantage is that it can give you much better results. Now, let's talk about printing inlay. The printing inlay, I think I'm using that a lot nowadays clinically, but the final materials are now available with resin and others. So as you can see in this case, MO cavity and O cavity, two printing inlays were prepped, and in the CAD software, the inlay was designed. In the milling inlay, the CAM software tools were used, and the inlay position in the blocks was set. And in other words, it was about CAM operation, but in 3D printing, the same CAM approach can now be done with the slicing approach. So, and also you also need to use supports, and how to use that support is all that shapes are explained in the far left image. So you put that in the 3D plate, then print, then the next two pictures are just right after printing. So if you see enlarged image, the two shapes are quite good. And now 5 or less than 5 micron, or less than 15 micron, that precision level is now possible. So technically, there's not much of a problem anymore. But in terms of preciseness, other things needs to be improved. But I'm sure quickly the printing inlay will become the preferred option. And with the printing inlay, printing one or more than or multiple inlays takes the same time. In other words, mass production is very much possible, and that is a very attractive advantage. Now, 3D printed inlay, after all the processing is done, just before we deliver to the mouth. And as you can see here, the margin precision is really good, but maybe in fit in the mouth for the patient is currently being improved. So let's look at that. So this is the margin fit, and for printing you use support. So I didn't remove the support, but just delivered into the mouth as is. And used that as is for adaptation, and it was quite good fit. And using resin bonding, the bonding was done, and using resin cement with the curing, it was set. Then removed support, and excess resin and occlusion was adjusted. Then this type of inlay can be made. Resin inlay is made with resin, so adding is easy, and also removing or cutting compared to old ceramic or gold inlay, it's much easier. So if we can make more improved in fit, it will be better. But even now, these materials can be used clinically without much of a problem. Another case. So O cavity inlay in the same method, it was designed. So as I explained before, using the slicing software, I put in various inlays. With the one-lay inlay, the biggest advantage is that it takes the same time to do multiple implants at the same time. Within 10 or 20 minutes, you can do everything. So in making inlay with the one-day approach, if the patient needs to have many inlays, then one visit is sufficient to do all the work. So it's very attractive option. So this is how inlays were made. And this is how it was delivered into the mouth. The margin adaptation, it's a bit falling short, but as the resin is used, as you can see on the right side, very good fit can be achieved in the setting. And also strength-wise, in my opinion, of course, there's a bit of room for improvement, but I think it's quite satisfactory and sufficient. Another case, on the posterior, two were prepped and scanned and designed using the 3D printer, inlay printed, and this time the support before it was adapted to the patient were all removed, and the inlays were made and fit into the mouth. Now the fit and others are all being now improved, and rather than adapting with the support to the patient, support and other things are all removed before being delivered or adapted to the patient. So I think with such advancement, it can have much more satisfactory results. Now I talked to you about the one-day inlay design. So let's answer some of the questions you might have through Q&A session. First question, if you do clinically one-day concept for inlay, what are the advantages and disadvantages? I think there are much more advantages than disadvantages in the one-day inlay concept. The biggest advantage is that everything can be finished within a day with one visit. If everything can be completed, then for the patient and also for the clinician, time-wise and also financially, it's very attractive. All the more with the adoption of CAD-CAM system, with the CAD-CAM software, 3D printer, and oral scanners advancements, compared to when you had to remove the analogly, like you have to do rubber impression, you have to do stone work, and in CAD you do design, but in actual inlay, manually you have to make the inlay, which takes a lot of time and efforts. But now with the help of CAD-CAM system, time has been cut short and the steps have been simplified. So the inlay production time, effort it takes to do that, and time you need to set and deliver to the patient are all saved. So one visit is sufficient, and that is the biggest advantage. But what are the disadvantages? First, resin printer or the milling machine or device, when you use the all ceramic or hybrid resin, all these materials strength, there's room for improvement. And secondly, actually inlay, if you make it with the CAD-CAM, then devices that you didn't need before, like milling device or scanners or design softwares, are now needed. But I believe that if you seek support of the digital dental lab, then you need only oral scanner at your clinic to do the one-day inlay approach. So there are much more advantages than disadvantages in one-day concept. Second question. I believe that printing inlay compared to milling inlay is not as precise. So in the current system, the printing system compared to milling system in many aspects, milling system do deliver higher quality results. this is not only for inlays, but also dentures. The printed denture versus the milled denture, if you compare to the fit and others, the milling denture is better. But compared to what you create with your hands, the printing inlay, I believe, is better. But still, printing inlay come with also other advantages. Mass production is possible, and the production cost is also low, and the time compared to milling is also shorter. And again, as you can make many inlays at one go, of course, it might be not as precise, but I do believe going forward, printing inlay will be the preferred option. And as I showed you with actual cases, as the precision level keeps improving, I believe that very soon it will be as precise as milling inlay, in my opinion. So third question, the company has chair-side customized system, and without that system, many say one day would not be possible. Can we use a general CAD-CAM system for one-day approach? Now, I believe this person studied a lot about CAD-CAM system. Yes, it was so up to now. I think what is the companies you are referring to, but their CAD-CAM system has been customized for one-day approach. This is because milling and design time it's very short with this system, so one day was possible. But that chair-side systems, I think disadvantage was that the scalability or expansion in clinical cases were limited, so you cannot have everything, but that made really challenging. And using general CAD-CAM system to do one-day approach was not attractive because it took a lot of effort and time. But with the 3Shape and SCAD and other milling machine devices and OSSTEM's 3D printers or OSSTEM's milling machine devices, if you use them, then time-wise you can really shorten it a lot, and it's very economic and it's very precise. So a lot of constraint has now been overcome, and all these are now available at your clinical setting. So without this customized system with the general CAD-CAM system, I believe one-day approach is now possible. Now, I believe because I need to finish this lecture within the limited time, I might not have solved all your or answered all your questions. But offline lecture is available, and I hope to see you then. And next time, I will see you with a new lecture. Thank you for your attention.
시청해 주셔서 감사합니다.